Hi everyone. So in this video, let's look at the next rate limiting algorithm that we'll be implementing. That is the leaky bucket algorithm. So as the name suggests, leaky bucket algorithm is something where we have a bucket which is leaky. That means a bucket has a hole inside of it, right? So what really happens here? We will have a set number of tokens and which means that this bucket has a capacity, a maximum capacity, and then there will be some leak rate associated with it, right? So for example, let's say this bucket has a capacity of, let's say, 5, which means that it can accept 5 requests and then it will have a leak rate. So the leak rate, let's say, is 1 per second, right? So what does it mean? So basically what it means is that this bucket has a capacity of 5, which means that it can take up 5 requests at a time. It can serve 5 requests at a time, and then the leak rate is 1 request per second, which means that every second this capacity will be restored, right? So let's say if 5 requests are currently there in the bucket itself, 5 requests have come up and 5 requests are there in the bucket. Every second one request will be thrown out of the bucket, right? Which means that every second, let's say we have 5 requests coming onto the bucket, and in the next second one request leaves away, so we have 4 requests that are remaining, which means the bucket capacity uh, is not full, which means we have one more request that can be accommodated. So in this way leaky bucket algorithm works. Right. So basically, we will be taking up requests from the client or from anyone. Whatever request will be received, those requests will be taken up and thrown in this bucket in the form of tokens or anything we can say. So when these requests are stored, these requests will also leak out of the bucket, right? And why is this so? Because it allows us to maintain the traffic that is coming onto the website, right? Coming onto the server or anything. Because if you see, if you have a capacity of 5 and then you are leaking 1 per second, which means that even if you have 5 requests, you always are going to have a space for another request only when a request leaks out of the bucket. And for that request to leak out of the bucket, it is going to take 1 second, which means that we are going to serve any request at a specific duration of time in a specific rate, right? Which is 1 second in this case. So which means that for every request to be executed, for every request to be served, we need to wait for that 1 second. In that 1 second, a request will be thrown out of the bucket, and only then the next request will be served, right? So let's try implementing this and let's try understanding this better. So I'll just create a new class. So we'll be implementing it in the same way. So we have a leaky bucket rate limiter.js. We'll create a class. First of all, let's declare Redis, require Redis. Then we have a class called as leaky bucket rate limiter, and in this we have a constructor. In this constructor, first of all, we will be having this dot bucket capacity as we have discussed. So the bucket capacity that we will be keeping would be, let's say, 5, right? And along with that, we also need the leak rate, which is 1 per second, which we have kept here. So I'll keep it as leak rate, and it should be 1. Let's say it's 1 for now. Let's keep it as 1. And it is in seconds, right? So it is in seconds. And also we need a client for connecting to Redis. Right. So first function would be the connect function. Let's just copy this function from here. Let's not work around this. Yeah, so this is the connect function that we have, and then we have a limit function which will have the logic that we need to write. Okay, so we have a request, response, and next. So in this limit function, we'll be writing the logic of leaky bucket. Okay, so first of all, what we need is the IP. So rec dot IP is the first thing that we need, which will be the key to store anything that we want to in Redis. Okay, so the first thing that we will do is we need to get this information from Redis. So in Redis, what we are going to store is that we will be storing the last updated time, which means the last request which came up onto this from this certain IP. We need to store the time of that last request. And if that last request, uh, if the last request and the request which is coming up now, so what we will be doing here, so let's write this down, it will be more clear this way. So first thing what we will be doing is get the last updated time and the number of tokens and the number of available tokens from Redis, right? So this is the first thing that we are going to do. So what are these tokens? Basically, these tokens are nothing but the amount of requests that have been come up and are into the bucket, right? And these tokens are something that are keeping track of the requests of from a certain IP and how many of them are in the bucket. So for every IP, there is going to be a bucket which is leaky, right? And with every next request that is coming up, we are going to throw out some of these tokens as and when required. How are we going to do that? Let's see. So first, get the last updated time and number of available tokens from Redis. Now, once we have number of available tokens, the next thing that we need to do is we need to find the difference between current time and the last updated time. Right. Now, difference between current time and last updated time, if it is, if it is greater than or equal to, if it is, okay, so we have a difference between current time and last updated time. So if this difference, so whatever is the difference, on the basis of this difference, we will be calculating time, and every second one token has to go out, right? So the number of tokens that will be, so we now have difference between current time and last updated time, which is nothing but um time elapsed, let's say time elapsed. Okay, so if the time so from time elapsed, we are going to see how many tokens have to be leaked. So number of tokens to be leaked is equal to leak rate into time elapsed, right? As we can see, this is 1 per second, where you multiply it with with the time elapsed with the number of seconds that have passed by, it will give us the leak rate. Now, once we have this leak rate, but it will give us number of tokens that are to be thrown out, right? So let's say if at t is equal to 6, t is equal to 0, we have 5 tokens already present, and then if you go at t is equal to 10, so in those t from 0 to 10, you have 10 seconds that have passed, and 10 into 1 would be 10, which means you need to throw out 10 tokens out of the bucket, which means that the capacity is going to be so the capacity doesn't come up here. Okay, so 10 tokens have to be thrown out of the bucket, but we have the capacity as 5 only, which means we had already 5 tokens, so all those 5 tokens will be flushed out of the bucket, right? And with every, so what we are doing here is we are not going to keep a track of every token and at what time was it, at what timestamp was it taken up, and then calculate on the basis of that. But what we are doing is we are just taking the last updated time and the number of available tokens from Redis, right? So the only two things that we are storing for a certain IP is the number of available tokens and the last updated time, right? So now in this case, so then as we saw, from t is equal to 0 to t is equal to 10, the number of tokens that were taken up were 5. So when we calculate number of tokens to be leaked, it was 10, which means greater than 5. We have to flush all the tokens out of the bucket, right? So this is something that we are going to do. Number of tokens to be leaked is leak rate into time elapsed. Okay, so now the number of tokens that are to be leaked are we have those. Okay, so one thing that we can do here is last updated time and the number of used tokens. So let's do this. Let's store the number of used tokens in Redis. Okay, so you have certain number of used tokens, And now we need to update use tokens is equal to max of 0 comma uh, number of leaked tokens. Right, because if you see leak tokens, okay, so it won't be number of leak tokens, but use tokens minus number of leak tokens. So in from t is equal the example that we saw from t is equal to 0 to t is equal to 10, 5 tokens were there. Right, within 10 seconds, all five should go, which means this equation that we have, use tokens minus number of leak tokens, will give us minus 5. We don't want to go to minus 5, it will be simply 0. So use tokens is 0 now. Okay, so now that we have used tokens, we can now apply a condition. If used tokens is greater than or equal to capacity, then then we can simply throw the request out, which means we drop the request. Else, what we do is we increment used tokens, and also use tokens is implemented and save the last updated time and used tokens in Redis, right? So this is what we are going to do. These are the few steps that we need to implement. Okay, so first of all, what we got is the IP. So const IP is rec.ip. Okay, so what we'll be doing here is that we will be storing this in the form of JSON in Redis. And yeah, I mean, that's not a big deal. We'll just simply store it in the form of JSON and then get it out in the form of JSON, right? Okay, so first of all, what we need is we need to have. Okay, so first of all, get the latest last updated time and number of used tokens from Redis. Okay, so the first thing that we are going to do is we are going to have the last updated time, which would be equal to JSON dot parse. If we have JSON dot parse for a string, so the string would be this dot. Okay, so we need to get this from the get this from Redis. So Redis data would be equal to await await this dot client dot get for a certain IP address, which is IP. Once we get this, what we can do is I can simply now I can simply extract this. So for const used tokens equals uh, parse int. So in Redis we are going to store it in the form of a string, right? So parse int of parse JSON dot parse of Redis data dot so JSON dot parse of Redis data. Okay, so let's do one thing. Const data equals JSON dot parse of Redis data, and yeah, so let's also add an await to it. Once we have this, we can simply say const use tokens equals data dot use tokens, and I can simply put it in a parse int of data dot use tokens. Along with use tokens, we also need to have the last updated time, right? So it should be last updated time equals parse int of data dot last updated time. Okay, so these are the two things that we have. We have used tokens and last updated time. Now the next part would be difference between current time and last updated time is time elapsed. Okay, so the time elapsed, let's calculate the elapsed time. That would be the difference between current time. So current time is date dot now, which let's take it up from here. Const current time equals date dot now, and current time minus elapsed current time minus last updated time. Yeah, so we have elapsed time as current time minus last updated time, but this is not going to be in seconds. So we will be dividing this by 1000 here. So we have it in seconds now. Const elapsed time is in seconds. Now number of leaked tokens. Now tokens to be leaked should be equal to used. So it should be equal to the this dot leak rate into elapsed time. So these are the number of tokens that are to be leaked, which will be subtracted from used tokens, right? So we have tokens to be leaked as well now. Okay, so the next thing that we can do is uh, tokens. So let's just keep it as tokens, and that would be used tokens minus tokens to be leaked, tokens to be leaked. So if this leak if this okay, so if the elapsed time is less than a second, let's say we have 5 tokens completely used. So if used tokens, the value of used tokens is 5, and then there comes the next request, which comes up before 1 second. And if that comes up before 1 second, which means that this request should not be served. So what we calculate is const tokens is equal to use tokens, which will be 5, and tokens to be leaked would be 0, right? So this dot leak rate is 1 per second, and if elapsed time is less than 1 second, then okay, so tokens to be leaked, I'll have to change this to integer, obviously, math dot floor. So we have tokens to be leaked as okay, so the tokens to be leaked would be 0, and then we will calculate use tokens minus 0, which will give us use tokens, which is 5 in the scenario that we were looking at. So if it is 5 or whatever, 5 or more than 5, anything, then we can check for it. Okay, so const uh, tokens, let's keep it as tokens in action. So the next part would be check if tokens in action is greater than equal to this dot max capacity, this dot this dot bucket capacity. If it is greater than or equal to bucket capacity, we will simply say return response dot status of 429 dot we have a status, and then we will also send too too many requests, try again in a little while, right? So if tokens are greater than equal to this dot bucket capacity, we will do this. Otherwise, what we need to do is use tokens has to be incremented. Okay, so now we won't increment it directly. We will simply do, okay, so we'll have to increment. Okay, never mind. So what we can do is we can have a new Redis data. So we have, let's say, a new Redis data that has to be put in. So in the new Redis data, what we are going to have is we have last updated time, which is going to be current time, and also we have used tokens, which is going to be used tokens plus 1. Right. So this is the new Redis data. I just need to convert it into a string and then save it in the client Redis. So I mean save it into Redis. So this dot client dot set for a certain IP new Redis data dot okay. So new Redis data JSON dot stringify also const data to be saved equals JSON dot stringify of new Redis data. Once we have this, we can save it to data to be saved, and this should do for us. Fine. So we have written the logic as much as we can. Now let's try test this out. If it works, const leaky bucket rate limiter equals required dot slash leaky bucket rate limiter, and just initialize this. So we have a connect function, and then we have a limit function as well, but it is creating a problem. New leaky, okay, so this is not exported, I guess. Yeah, So this is not exported, module dot exports equals leaky bucket rate limiter. And now this should work. Let's see if I can just hit with the curl. It is giving some error, wrong type operation against a key holding the wrong kind of value. Okay, so there are a few things here. So for the first time, when there is no Redis data, if we don't have anything in the Redis, then it will give out this as null. So JSON.parse will not work in that case. So if we have Redis data, then only we are going to have this await statement. So I'll just say if Redis data, then call await JSON.parse. Otherwise, we will set this as use tokens to be 0, and then we have last updated time as I think it should be current time itself. Okay, so yeah, so it should be current time, right? I mean, it just won't matter anyways. So current time dot to string. Okay, so this should work now. Along with that, I also found something. So here, this can go turn out to be negative. So we need to add a math.max function. If it turns out to be negative, it will be set to 0, right? So now let's try executing this. Okay, we have the same error. Okay, so one mistake over here is that we cannot use tokens. We need to use tokens in action, right? Because use tokens are always there, but when use tokens are we also need to subtract tokens to be leaked from use tokens, and then we have tokens in action, which is to be updated, right? So yeah, we have this, but there is some error that is coming up, wrong type. Yeah, so why is it occurring? Because I had implemented the sliding window rate limiter, right? And for sliding window rate limiter, we are saving an entire array or list in Redis. So when we are trying to get this out of Redis data, it is creating a problem for us. That is why I'll have to empty my Redis entirely. Okay, then I'll say Redis CLI flush all. Okay, now this has worked. Keys loaded is 0, and that's all we wanted. Now hopefully this should work. Now let's restart the application and let's hit onto it. Yeah, so the first request that we have has been successful. It says welcome to the application. And if I keep on hitting, yes. So now this is working. As you can see, after 1, 2, 3, 4, 5, okay, so let's do one thing. We might not be in the position to understand it this way, so we will try to let's try to put this out here. Okay, so tokens in action, we have tokens in action. Then okay, use tokens. Okay. Okay, so let's do one thing. After tokens in action, let's console.log uh, tokens in action. We have tokens in action. It is use tokens minus tokens to be leaked. So tokens available. Let's keep it as tokens available, and the token number of tokens that will be available would be this dot bucket capacity minus tokens in action, right? So now we can actually will be actually able to see how this exactly works. Okay, so let's try curl. So tokens available is 5, 5, 5, 4, 3, 2, and we'll have to do it quickly because the limit is only 1 second. So as you can see, some of these requests are not being served, too many requests, try again in a little while. And some of these requests are being served because after every second that token is being released, and as you can see, we have tokens available as one, then this token is used up, we have it as zero. But in the next second itself, the token which was already present is then leaked out. So again, we have tokens available as one, and this keeps on going, right? So this is how we implement the leaky bucket rate limiter. And yeah, so that's all from my side. Thank you so much.